this video, we are going to focus on factorizations of the expressions of the form ax2 plus minus bx plus minus c. Once again, I strongly focus here to know the structure of the expressions, because knowing the expressions gives us the idea of choosing the correct method. Okay, so it is ax2 plus minus bx plus minus c. I want to compare what we have done in the previous class. In previous class, we have factorized these expressions. Now, what is the difference between the previous class expressions and these expressions? Okay, if we observe properly, then we will clearly find out. Here the leading coefficient is 1 here, and the coefficient of x square, that is leading coefficients in this expression, is a, that is other than 1, that is non-1. So this is the difference. So because of this difference, we have to use different method here to factorize. Okay, little bit different method we have to follow here. Okay, so here also we have to make the conditions similar to the previous cases. Okay, and to make the condition here, constant term and that coefficient of the middle term was used here. Okay, in the previous, that 14 and 48 and 14, that is used here to make the conditions. But here we have to use all three copies, that numerical coefficients. Okay, 5, minus 14 and minus 3. Okay, so how they are used? Look at here. Here we need to find two numbers r and s that multiply it, not 3, only 3 here. In previous we have used only that constant term, but here we have to use first and last numbers. They are 5 and minus 3. Okay, that is minus 15. So making the condition here, for the condition of multiplications, we have to use minus 15 here. Okay, let me tell you, in the previous only that constant term was used here, but where leading coefficient is other than 1, then we have to use that coefficients also and the constant term also to make the conditions for multiplications. And that a2, that is same, that is coefficients of the x, that means minus 14. Okay, so only difference is here. In the previous, in the form of x2 plus minus bx plus minus c, we have used constant term only to make the conditions of multiplications. But where there is other than 1 the leading coefficients, then 5 and minus 3, that is first term and last terms, are to use to make the conditions of multiplications. So this difference you have to keep in mind. Okay, and other process are same as the previous that we have done in previous classes. Okay, so again we have to search here two numbers. Okay, that gives the two conditions, that satisfy the two conditions. One is multiplications should be minus 15 and additions should be minus 14. Okay, I suggest you uh, to make this table, okay, that gives you clear idea of finding two numbers satisfying the two cases. Okay, 5 by repeated division method, 5 3 ja. Okay, so 15 with the number 1 is always the factor of 15. Okay, so it gives 15, but according to conditions we have here minus 15. That products will be minus, so it should be minus. So what gives minus here? One of the negative numbers gives minus, so look at here. And now the condition is minus 15 plus 1, that is minus 14. And another 15 multiply minus 1 also gives minus 15. Okay, and second conditions, does the two number 15, their sum should be minus 14. And another 5 3 ja, 5 3 also, 5 3, but one of the numbers should be negative, so it is what, it is minus 15. And minus 15 minus 5 plus 3, it gives minus 2. Another number also we have to use here, that also give minus 15. So, and here 5 plus minus 3 give 2. Okay, these are the possible pair of numbers that satisfy these two conditions. Okay, these two conditions. So after writing all the possible combinations, there must be one which satisfy both cases. Yes, so sum should be minus 14. So this second cases satisfied both conditions. So 15 and minus 1 are the two numbers that we are looking for. Okay, so after finding these ones, then the factorizations is easy, that you have already done. Okay, now 5x squared minus 14x minus 3. So in place of 14x, what do we do here? This u is here. In place of minus 14, we have to use 15 minus 1. So here in place of minus 14, we are going to write 15 plus minus 1. So here we have to write plus here, because plus, in place of minus 14 we are going to write this one. So minus 14, if we write minus 14, then it must have plus 4 here. So that is 15 plus minus 1 x minus 3. Okay, so 5x squared and plus, if you multiply this one, then it becomes 15x, and it is what, it becomes plus minus x minus 3. Okay, so minus plus, it will be minus, so no need to write this plus. Now from here, 5 is what, greatest common factor, and x is also common, so 5x is taken common. So if we divide 5x squared by 5x, then x left here. If we divide 15 by 5, it is 3, and if we divide x by x, then only 1. And here we can take minus 1 common here. So if we take minus 1 common, then it becomes x, and minus it becomes, if we divide minus 3 by minus 1, it becomes plus 3. Okay, so most students get confused here. So look at here, when minus is taken common, then you have to divide that one, so it becomes plus, so this also become plus. Now x plus 3 common, x plus Look, this way it is factorized. Okay, so finding these two numbers that satisfy the condition is little bit challenging. Others are very simple. So students, be careful about this. Okay, let's see another questions. I have taken the questions having negative. Some of you were confused when there were negative in the previous classes. So let's see clearly. And look at here. 3 minus 11 minus 20. Okay, they are used here to make the conditions. So we need to find the two numbers R and S that multiply, not minus 20 here, because the leading coefficient is 3 here. So for the conditions of multiplications, when leading coefficient is other than 1, then that also should be used. That means 3 multiply minus 20. 3 multiply minus 20. It is what? Minus 60. Okay, we have to use minus 60. And that 8 2, not 14, that 8 2 minus 11. Okay, at first we have to make the condition like this. Okay, now we have to search the two numbers that satisfy the both conditions. Okay, for this one we have to 60, we have to factorize, we have to do prime factorization. Three 5. Okay, so in place of 60 we can write 2 2 3 5. So let's make the tables for the systematic process. Products will be R and S. Products will be minus 60 and sums will be minus 11. Okay, so minus 11 and minus 20 we have to use here. Okay, so 60 means 2 30 ja, 2 30 ja, so 30 2 ja, we know it is 60. Yes, but it is minus 60, so one of the this will be minus. Now what will be their sum? That is minus 28. This is not we want. Another's 30 and minus 2 ja, it is what? Minus 60, and their sum is 28. So this is also not the numbers that we are looking for. Another's 2 2 ja 4, 15 ja, yes, so 4 15 ja 60, so one of the numbers will be minus. So what is their sum now? Their sum is 11. So this is not we wanted. Another's 15 minus 4 ja, it is also minus 60. So let's check their sum. Okay, this minus 15 and minus 15 plus 4, it is minus 11. Okay, so this is the number which we want. Okay, so This process is only to find the that numbers that satisfies the conditions. So after finding the numbers, you can end the process. Okay, so this is which we are looking for in the solutions. Now after finding numbers, then we have 3x square minus 11x minus 20. So in place of 11 we can write here minus 15 plus 4. Okay, and another way that in place of 11 we can write here 15 minus 4 also. Yes, so 11 means 15 minus 4, x minus 20. So this is 3x square minus 15x, and minus it makes plus, so it is 4x minus 20. So from here 3x is common, so x minus 5, and from here 4 is common, that is what, x minus 5. Again x minus 5, that is common, 3x plus 4. Okay, this is the factorizations of these ones. Okay, again students, let me tell you here, in place of minus 11s we can write here minus 15 plus 4 also. Yes, and in place of only 11 we can write here 15 minus 4 also. So you should not get confused here. You can use this one also, you can use this one also. Okay, so after finding the two numbers that satisfy both conditions, you can do like this also when there is minus. Okay, so that is what done here.